Hello everyone, welcome back to the second video about me creating a buck converter. I found a circuit on Wikipedia and drew it myself on this nice piece of paper so I can share it with you. I then built the circuit on this breadboard. Although it is functional, it is not useful. It can only switch about 4 watts of power before the diode over the inductor gets too hot. Let me show you. This is the oscilloscope with the PWM signal at about 85% duty cycle. And then when I take my power supply, take it up to about 10 volts, we can see about 0.4 amps. That makes 4 watts if we multiply it by the 10 volts. In this heat image over here, you can see that the diode is getting hot. And it's getting increasingly hot, unlike the diode next to it. That means that if I leave it on too long, the diode will just disintegrate itself. If you do not have a heat camera, you can also use some grease and put that on components you suspect of getting too hot. The component that is starting to smoke is your suspect. Now, what am I going to do? The diode I just mentioned, that's getting hot, I will replace that by a bigger diode, a TU22 format diode. It looks like a MOSFET. It has actually 2 diodes inside. It can handle about 10 amps, but since I'm only going to use the one MOSFET, it will be about 5 amps it will be able to handle. Later, if this thing is still getting too hot or cannot handle the current, I can also use the second leg and thereby the second diode. But for now, with just a heatsink on its back, some thermal components, some thermal paste and a screw to keep them together, I will now install that onto the board. First, I need to remove the old diode, like this, put it aside, then orient myself on where the leg of the inductor is, so I know how to put the diode in. Alright, that's it. Now I need some connector from the ground also to the diode, and then from the diode into the inductor. This one is a bit finicky to get in. Just remove this one for a split second. Okay, there we go. That one is in. Please allow me to focus. Yes. Yeah, that's good enough. Let's replace the diode. Orienting the diode is now a bit easier because of those connections I already made. Okay, there's some wire under it, but that's not too important. I'm also going to need a bigger lamp. This one does just not have the wattage I need, so I prepared another one. This one. It has some header pins to it. That makes it a bit easier to connect to the board than the previous one. I said quite openly. Okay, this is the first one. Click. And then one to the ground. And the lamp is connected. I'm not quite fond of the orientation. Can I do something about it? Yeah. That's a bit better. I have the light shine away from me because I get blinded by it. Okay, now if I put the... Is this better? Yeah, that's better. 30 watts already. No, 45 almost. Okay. Let me put that down and start with my heat camera. Heat camera. That takes some time to boot. I can already smell where the lamp has touched the paper. Okay. Now the circuit can take about 45 watts. I just took an image with the heat camera, and that showed me that it is now the MOSFET that is getting hot. It was about 70 degrees. I'll include the image right here now. So that will be the challenge for next video. Thank you.